Most exciting part of chapter 5 here, dividing polynomials by polynomials. This is our polynomial long division. Long division of polynomials says here, write the dividend and divisor in descending powers of the variable. What does that mean? We're going to divide two polynomials. Make sure they're in standard form. That's all that is. Dividing two polynomials, make sure they are in standard form. Number 2, insert placeholders with 0 coefficients. In other words, if you have x squared plus 7, where's the x? X squared plus 7, we're going to go ahead and write that as x squared plus 0x plus 7. Just insert that 0 coefficient placeholder for whatever term is missing. It will ensure that you do not get your steps messed up when you are dividing. It's very crucial you do so. Step 3, perform the long division of the polynomials as you would with integers. When we do this division here, we're dividing polynomials. We still want to keep in mind our quotient rule for dividing back in section 1. By subtracting the exponent, but we're going to move about it the same way we did using our division algorithm. Last there, continue the process until the degree of the remainder is less than that of the divisor until you exhaust all possible outcomes. Here we go. Let's go ahead and take a look at an example. Here we have the trinomial x squared plus 2x plus 4. This is being divided by the binomial x minus 1. How do we want to start here? Looking at the largest term in our divisor, x minus 1, we're looking at the x. Looking at the first term in the first term in our divisor, the first term in the dividend, we have x and x squared. The question is, how many times will x divide into the x squared? In other words, x squared divided by x is x. You see there that x squared divided by x is x. So now when we take the value at the top x, what did we do in the numerical algorithm? We would take that value and multiply it back to our divisor. So now the x that we wrote at the top, multiply that to the x minus 1. X times x is x squared. X times a negative 1 is negative x. We will subtract that from our dividend, and we will find the remainder, because then we will look to subtract it as we do, right? Division is repeated subtraction, so we will subtract this to find a remainder, and we will divide the x minus 1 into our remainder, just as we did with our division algorithm. So x squared plus 2x, subtract the x squared minus x. The x squareds will cancel. Positive 2x subtract a negative x is positive 3x. Bringing down the next term, just like we brought down the next digit in the division algorithm, we will bring down the next term, which happens to be the positive 4. And notice that there are no other terms to bring down, so this will be our last division of the remainder. Looking at the remainder, what we have left over, 3x plus 4. The largest term there is the 3x. For what we're dividing by, our divisor x minus 1, it's x. So how many times will x divide into 3x? 3x divided by x is simply 3, or plus 3. A positive 3 now multiplied to x minus 1. Positive 3 times x is positive 3x. Positive 3 times negative 1 is negative 3. Subtracting the 3x plus 4 and the 3x minus 3, we see that 3x minus 3x will cancel. A positive 4 subtract a negative 3 is the same thing as positive 4 plus 3, which is 7. So what we gather from this, x squared plus 2x plus 4 divided by x minus 1 gives us a result of x plus 3 with a remainder of 7. How do we write that quotient or that result there? We write it as x plus 3 plus our remainder of 7 divided by our divisor x minus 1. And that would be our quotient, that would be our remainder, our divisor, that is our result of dividing our polynomials. Make sure to write each polynomial in standard form. So we are going to perform the division here. Divide 21 minus 4x minus x squared by the binomial 3 minus x. So my first trinomial, I'm going to write it in the standard form, negative x squared minus 4x plus 21. And I'm dividing by negative x plus 3. How we do the long division for polynomials. We have now completed step 1 by writing them in the standard form. I don't have to worry about inserting placeholders. I'm not skipping any terms here. Degree 2, 1, 0, degree 1, 0. There is no skipping between first and last. Perform the long division as you would with integers. This negative x plus 3, we want to know as we move along the terms, what can they divide into? We focus solely on the first term. I'm going to go ahead and go to the full screen. We will focus solely on the first term of our divisor and the first term of our dividend. How many times can negative x divide into negative x squared? In other words, what is negative x squared divided by negative x? Well, a negative divided by a negative is a positive. So we know they will cancel. X squared divided by x is simply x. So we see here, how many times will negative x divide into negative x squared? X times. So we will write x on top of our dividing bar, our doghouse as some call it. And now what we write at the top here, this x that we just got, we are going to multiply that to our divisor. X multiplied negative x is negative x squared. X multiplied positive 3 is positive 3x. Division is repeated subtraction, so we will subtract these two to find a remainder. The example to the previously to this didn't put this in parentheses and show the subtraction, but understand that this is now going to subtract this amount. Well, this number and this number is exactly the same. Although they're negatives, they're the same exact value. Negative x squared, negative x squared. I'm subtracting this number from itself. That cancels every time. That's 0x squared. A negative 4x minus positive 3x. Again, if you want to consider, like we learned in the last sections, in 5.2, distribute the negative sign, change each of the signs here, and then just combine your terms. When you subtract the positive 3x, this becomes negative 3x. When you combine negative 3x with negative 4x, you get negative 7x. Again, as we see, negative 4 minus positive 3, negative 4 minus 3 is negative 7. 0x squared minus 7x, we will simply write this as minus 7x. And so we use these two terms here in our dividend. We haven't used the plus 21, so we bring it down. Plus 21. So we ask ourselves the question, with the first term here, negative x, and the first term here in our remainder, negative 7x, how many times does negative x divide negative 7x? In other words, what is negative 7x divided by negative x? A negative number divided by a negative number, the negatives cancel. 7 times x divided by x, well, x divided by x is 1. 7 times 1 is 7. So that's why we say there, when you have a factor top and bottom in your fraction, they cancel. Because any number divided by itself is 1. 1 times 7 is 7. Thus, your only factor remaining is 7. Thus, negative x divides negative 7x 7 times. 7 is positive, so we write plus 7 at the top. This positive 7, we will multiply to our divisor. Positive 7 times negative x is negative 7x. A positive 7 times positive 3 is positive 21. We need to subtract. Division is repeated subtraction, so we need to subtract to see if there's a remainder. Negative 7x, subtract negative 7x. And let's go ahead and distribute to see what happens. If we're subtracting this remainder here, let's distribute the negative, and by distribute the negative, we change the sign for each term in parentheses. The minus 7x, we're subtracting it, so this becomes positive 7x. Subtracting positive 21, this becomes minus 21. And so now we can drop the parentheses, get rid of that subtraction sign, because now we have changed the signs inside parentheses. Minus 7x combined with a positive 7x, well, that's 0x. A positive 21, a minus 21, well, that's 0. 0x plus 0, of course, is simply 0. This tells us there is no remainder. No remainder means that this was a very nice, smooth division. Negative x squared minus 4x plus 21 divided by negative x plus 3 is x plus 7. In other words, we can also state that negative x plus 3, when multiplied to x plus 7, this will actually give us the resulting trinomial. And we can show that for a challenge. Multiply this out using the FOIL method and combine like terms with the inner and outer product, and you will see that the positive 3x minus 7x is minus 4x. A negative times positive x is negative x squared. Positive 3 times positive 7 is positive 21. This verifies for us that, yes, in fact, if you were to divide this trinomial by this binomial, well, this trinomial is understood to be the product of these two binomials. And if you divide out by the negative x plus 3, you're getting rid of this binomial factor, leaving behind the x plus 7 with no remainder. Perform the division. 12x squared plus 17x minus 5 divided by 3x plus 2. Notice that the way this division is presented to us is in the fraction notation. When you write a polynomial expression over a polynomial expression, this is a rational expression. A rational expression is another way to show the quotient or division of two polynomial expressions. Let's perform this division and see what quotient or remainder, if any remainder, we happen to get. Now, what we want to start here doing is to write this in the doghouse form, the dividend under the box, the divisor on the outside. Now, again, we want to know, how is 3x plus 2 going to divide into the 12x squared plus 17x minus 5? Again, we're dividing, so we're reversing multiplication steps. Just think about things that we would need to multiply in order to get to here. How many times would 3x, looking just at the first term here, the largest degree, dividing the 3x into the 12x squared, what do we need to multiply to 3x in order to get 12x squared? 3 times what gives us 12? And then what do we need to multiply to x to get x squared? Well, again, we can see this by dividing. Right? What do we need to multiply to 3x to get 12x squared? We can find that by dividing 12x squared and 3x. 12 divided by 3 is 4. X squared divided by x is x. So we write 4x at the top. This is part of our quotient. But now we take that part of the quotient 4x and multiply it back to the 3x plus 2. 4x multiply 3x is 12x squared. 4x multiply a positive 2 is positive 8x. Division is repeated subtraction, so we will subtract these two to get a remainder. We want to subtract the 12x squared plus 8x, so distributing the negative, we get minus 12x squared minus 8x. Thus, we combine the like terms. 12x squared minus 12x squared is 0x squared. Positive 17x minus 8x is a positive 9x. Bring down the next term, which happens to be the final term, to give us a remainder of 9x minus 5. Now we want to know how many times will 3x divide into 9x. What do you need to multiply to 3x to get 9x? Well, that's 3, and we can show it by dividing 9x divided by the 3x. 9 divided by 3 is 3. X divided by x is 1. And 3 times 1, of course, is 3. So, because 3x divides the 9x 3 times, we will write the 3 up here. And that 3, of course, is a positive 3. Now, this term in our quotient, positive 3, we multiply to the 3x plus 2. 3 times 3x is 9x. 3 times 2, that's a positive 6. Division is repeated subtraction, so we will subtract to find a remainder. We're subtracting 9x plus 6, so we distribute the negative. 9x becomes negative 9x. The positive 6 becomes negative 6. Combining 9x minus 9x is 0x. Negative 5, negative 6, negative 11. So what do we have here? 12x squared plus 17x minus 5 divided by 3x plus 2 gives us 4x plus 3 with a remainder of negative 11. How do we express this answer? Our quotient here, our result is 4x plus 3 with a remainder of minus 11. We write it over our divisor 3x plus 2. So here our last term, not only is our result 4x plus 3, it's 4x plus 3 minus 11 over 3x plus 2. And this is our resulting expression from our division. 15 minus 4u minus 8u squared divided by 5 plus 2u. Performing the division, we notice we are dividing by a binomial, so we need to use long division. Rewriting each of the polynomials for number 32 in the standard form. Rewriting the 5 plus 2u as 2u plus 5, and rewriting our trinomial as such. Again, we take the dividend and place it under the doghouse, and we take our divisor and place it out to the left. Performing the long division, 2u divides negative 8u squared, negative 4u times. Negative 4u multiply 2u is negative 8u squared. Negative 4u multiply positive 5, negative 20u. Division is repeated subtraction, so we subtract to find the remainder. Subtracting this binomial, we distribute the negative. Distributing the negative, we change the sign of each term in the middle and drop the parentheses. Negative 8u squared becomes a positive 8u squared, and the negative 20u becomes positive 20u. Combining like terms, minus 8u squared, positive 8u squared, that's 0u squared, so we ignore it. Minus 14u plus 20u, 20 minus 14 is a positive 6. So we get here 6u. Bring down the next term, plus 15. 2u will divide into 6u 3 times, and 3 is positive. The term positive 3 in our quotient multiplied to the divisor 2u plus 5. 3 times 2u is 6u. 3 times 5 is 15. Division is repeated subtraction, so we subtract to find a remainder. 6u subtract 6u is 0u. Positive 15 subtract positive 15 is positive 0. 0u plus 0 is simply 0. Therefore, there is no remainder. So our quotient here, minus 4u plus 3. It can be easily verified that this is the correct result when dividing these two polynomials. If 3 times 5 is 15, then 15 divided by 5 is 3, and 15 divided by 3 is 5. Same thing here. If we take this trinomial and divide it by 2u plus 5, we will forever and always get minus 4u plus 3. If, however, we take minus 8u squared minus 14u plus 15 and divide it by minus 4u plus 3, you are guaranteed to get 2u plus 5. That is because if you multiply 2u plus 5 to the minus 4u plus 3 using the FOIL method, combining the like terms of the inner and outer product, you will end up with the trinomial minus 8u squared minus 14u plus 15. So that verifies that we have our correct quotient here, the minus 4u plus 3.